Let's solve the system of equations x plus 5y plus 4z equals to negative 3, x minus y minus 2z equals to negative 3, x plus 2y plus 3z equals to negative 5. Well, let's get rid of x's this time. So if we take the first and the second equation, and if we multiply the second equation by negative 1, our x's will drop out. So we'll have x plus 5y plus 4z is equal to negative 3. That's the first equation. Changing the sign on the second equation, we'll have negative x plus y plus 2z is equal to 3. So if we add, our x's drop out. We have 6y plus 6z equals 0. Now let's take the second and the third equation. Well, let's leave the second one alone and multiply the third equation by negative 1. So we'll have x minus y minus 2z is equal to negative 3. The third equation will have negative x minus 2y minus 3z is equal to 5. So adding our x's drop out, we have negative 3y minus 5z is equal to 2. If we divide this first equation by 2, we'll have 3y plus 3z equals to 0, and our y's will drop out. So let's do that. If we divide this by 2, we get 3y plus 3z is equal to 0. So our y's drop out, and we have negative 2z is equal to 2. So dividing both sides by negative 2, we have z is equal to negative 1. So now that we have z is negative 1, plug that in and find y. So this will be 6y plus 6 times negative 1 is equal to 0. We have 6y, this is minus 6, is equal to 0. So 6y is going to equal positive 6. Dividing both sides by 6, we get y is equal to 1. So now that we've found z and we found y, let's go to the first equation and find x. So x is going to be x plus 5 times y, which is 1, plus 4 times z, which is negative 1, is equal to negative 3. So we'll have x plus what? Well, 5 times 1 is 5, plus a negative 4 will be plus 1 is equal to negative 3. Subtracting 1 from both sides, we get x is equal to negative 4. So our solution is the ordered pair negative 4, comma, 1, comma, negative 1. So the solution to our system of equations will be negative 4, 1, negative 1.